Hi everyone, welcome back. So in this video, we are going to understand how to transform a given vector in spherical polar coordinate system into the Cartesian, and how to transform the vector given in the Cartesian to the spherical polar coordinate system. So this third would be the main topic of this video. But in order to do that thing, we must understand certain things. That is how we represent the unit vectors in spherical polar coordinate system, and how to use the transformational matrix or the rotational matrix between the spherical and Cartesian bases. Okay, and then we'll do the examples. And obviously, this topic is very important from any exam perspective. If you understand this topic, then you'll surely do great in quantum mechanics, in hydrogen atom, in angular momentum, in so many topics, and in classical physics, in finding the how to degree of freedom is, and then rotational kinetic energy, all those things. Okay, all those things, writing the generalized coordinates, and in mathematical physics, in matrices, in a lot of things. And electrodynamics, obviously electrodynamics is one of the important applications of the spherical polar coordinate system. So let's go directly into the topic. So see, if you haven't watched the previous videos on the spherical polar coordinates, then I would suggest to just go and have a look on those videos. But you can skip. Let's go directly. So I have made here a sphere, and some axes, x-axis, y-axis, and the z-axis. So they are conventional Cartesian coordinate axes, and this sphere is actually actually a spherical. Okay, it's a spherical shape on which we are going to use the spherical polar coordinate system. So basically, we cannot define the spherical polar coordinate system without defining the Cartesian coordinate system. So that's very important. Existence of spherical coordinate system is only when there is Cartesian coordinate system. We cannot define a spherical system without defining the Cartesian. So these x-axis, y-axis, z-axis are conventional Cartesian coordinate axes, and I have a sphere, and let there be a point on the sphere and its position vector from the origin. This origin is common to both the coordinate systems. So let's say this is the r position vector of the particle on the surface of the sphere. So how much this r makes with the angle, how much it makes an angle with the z-axis. So that's theta, and that this is theta. And now if this r has two components, one along the z-axis, let's say this one is r cos of theta, and another on the xy plane, this xy plane, that would be r sine of theta. So I have given the details about this thing in the previous videos. Now, how much this r sine theta makes an angle with the x-axis? So that is phi. So I have defined r, theta, and phi. So r is the position vector of the particle on the surface of the sphere from the origin. This origin is actually common to the Cartesian axis and the sphere. Okay, so how much this position vector of the particle makes an angle with the z-axis, that is the theta, and how much r sine theta, which is one of the component of this r on the xy plane, makes angle with the x-axis, that would be phi. Okay, I hope you understand now r, theta, and phi. So now if we see this r sine theta, now this r we can write from that z is equal to r cos of theta, because r cos theta is the projection along the z-axis. So z is r cos of theta. This one is the first equation. Now this r sine theta is one of the vector, and it has a projection on the y-axis and the x-axis, like this axis and this axis. So this time the vector is r sine theta. So its projection on the x-axis is r sine theta cos phi. This is like something basic, 10th grade physics. So x is r sine theta cos phi. This would be the second. And now this r sine theta has a projection on the y-axis. So that would be r sine theta sine of phi. So these three relations are very important. Now what we have to find, we have to find the unit vectors, and that is r cap. We have to find the r cap. We have to find the r cap, theta cap and the phi cap. Then we'll write the transformational matrix between the spherical and the Cartesian bases. In order to find the r cap, we'll use a basic definition of r cap is given by tau r vector by tau r divided by tau r vector by tau r magnitude. I'm using the basic definition of any vector, any unit vector. Unit vector is given by given vector divided by magnitude of given vector. This is the basic definition. But we don't know this r vector. How to find this r vector? See how to find the r vector. R vector is given by xi cap plus yj cap plus zk cap. This is simply the position vector of the particle. We know from the 11th or the 12th physics, if these are the x-axis, y-axis, and the z-axis. Z-axis, and there we have particle here having the position as the x, y, z. Then its position vector r is written by this xi cap, because its position is x along the x-axis, y along the y-axis, and the z along the z-axis. And now what we do here is that we can put r vector here as in terms of x. We'll write here this. So this is r sine theta cos phi I cap plus the plus in place of the y we'll use r sine theta sine phi j cap plus in place of the z we'll use r cos of theta and we have k cap. So now we are able to write the r vector. Now we have to partial differentiate this r vector with respect to r, keeping this. Okay, just here this r cap and this r is same. Don't get confused. Okay, it's like r. Maybe you might get confused. Let me replace it. It's the same vector. Okay, now this r vector is because this is the same position vector. Now position vector is this. I hope you understand this r. This is simply the position vector. Now we have to differentiate this position vector partially with respect to r, keeping theta and phi as constants. Okay, that's the very important thing. We move a small infinitesimal displacement along r, keeping theta and phi as constants. Okay, so let's differentiate it. Dou r by dou r. So basically it's the dou r by dou r. So sine theta and phi are constants. So sine theta cos phi I cap, because with respect to r we are differentiating, so it would be 1, plus here it would be 1 sine theta sine phi j cap, plus here it would be 1, so cos theta k cap. So this is dou r by dou r. So this is this thing. Now its magnitude is dou r by dou r. So it's, I hope you know any vector. If we have any vector like r is given by 2i cap plus 3j cap plus 4k cap, then magnitude of r is given by root of 2 square plus 3 square plus 4 square. I hope you know all these things. So dou r, its magnitude is given by root of sine square theta cos square phi plus sine square theta sine square phi plus cos square theta. Okay, so which implies dou r by dou r magnitude equals, so let's take sine square theta here common, so there would be sine square phi plus cos square phi is 1, so root of sine square theta, because this and this will go, plus cos square theta, which is again 1, root of 1 is 1. So I am able to write the unit vector of r cap. R cap is given by here r cap is given by dou r by dou r, I have written here dou r by dou r, and then dividing the magnitude, which is 1. So it's like directly this. So sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap. So this is the unit vector r cap in spherical polar coordinate system in terms of Cartesian I cap, j cap, and k cap. Now this would be the first thing. This would be the alpha equation. Now let's similarly find the theta cap. Let's find the theta cap. Theta cap would be dou r by dou theta. This is the vector divided by dou r by dou theta magnitude. Again, let's find this thing dou r by dou theta while keeping phi and r as constants. Okay, for that I would need this thing. This is the r vector because we have to partially differentiate it with respect to theta while keeping this is the r. Okay, let's write it now. Okay, so which implies theta cap equals dou r by dou theta. So we'll be differentiating with respect to theta here, theta, while keeping the r and phi as constants. So it's r sine theta would be cos theta and cos of phi I cap plus r sine theta would be cos theta sine of phi j cap plus r cos would be minus sine theta. So it's like minus r sine of theta k cap. This is the numerator part and its magnitude. So this same magnitude would be given by divided by root of this whole thing. So r square cos square theta cos square phi plus r square cos square theta sine square phi plus r square sine square theta. So basically theta cap would be given by r. Let's take r common from the numerator. So cos theta cos of phi I cap plus cos of theta sine of phi j cap minus sine of theta k cap divided by, so let's take r square common, and that would be outside, and inside the root there would be cos square theta. Let me take this cos square theta common. So there would be cos square phi sine square phi, which is 1. That then that cos square theta will combine with sine square theta, that would be 1. So it's 1. This r will go with this thing. So theta cap is given by cos theta cos phi I cap plus cos theta sine phi j cap minus sine theta k cap. So this thing is theta. This thing is theta cap. Okay, let me erase this now because it's 1 there. Okay, it's 1. So for phi cap, let me use a different pen here. Let me use this green one. Now we have to use the phi cap. For the phi cap, we'll use dou r by dou phi divided by magnitude of dou r by dou phi. Again, this is very simple. So phi cap equals, well r is same. This r is same. This r is same. Let me paste it here. So this r is same. For the sake of convenience, I'm writing it like that. So phi cap is given by dou r with respect to phi while taking r and theta as constant. So it's like r sine theta cos phi is minus sine of phi I cap plus r sine theta sine phi would be cos phi, and there is no phi here, so that would be 0 plus 0 k cap. So basically that's the vector divided by its magnitude. So this part is this. Now its magnitude is given by root of r square sine square theta sine square phi plus r square sine square theta cos square phi. Okay, so let's take this r common, so that would cancel with this thing. So there is minus sine theta sine of phi I cap plus sine theta cos of phi j cap plus 0 k cap divided by root of sine square phi sine square phi sine square theta sine square phi. Here is sine square theta, we can take sine square theta as common. There would be sine square phi plus cos square phi, so this is 1, and then sine root and this square gets cancelled, so there is sine theta, that sine theta will get cancelled with this thing, so there remains only minus sine of phi I cap plus cos of phi j cap plus 0 k cap. So we are able to write the unit vectors of spherical polar coordinate system r cap, theta cap, and phi cap in terms of I cap, j cap, and k cap. Now we have three important things, that is r cap, theta cap, and phi cap. Let me copy them. This is copy, let me put it here. So this is r cap, phi cap, and there is theta cap here. Copy, let me paste it here. So this is theta cap, and this one is phi cap. I hope you are able to understand how I derive. This is alpha, this is beta, and this is gamma. Now I can write a transformation matrix like this. So let me write it r cap, theta cap, and phi cap here equals this whole and I cap, j cap, k cap. Okay, so sine theta cos phi plus sine theta sine phi and cos theta. Okay, and here cos theta cos phi, it's not plus here. Okay, this is this part, and cos theta sine phi and minus sine of theta, and I cap minus sine of phi and cos of phi, it's 0 here. So this is basically the second part. So basically I was able to write the unit vectors in spherical polar coordinate system, and this is the transformation matrix between the spherical and Cartesian bases. You can see if you do this, so you can write r cap equals sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta k cap, and then you can do the second row and this thing. So cos theta cos phi I cap cos theta sine phi j cap minus sine theta k cap, and similarly minus sine phi I cap plus cos phi j cap plus 0 k cap. So basically this is one of the most important matrix. Okay, we call it as a transformational or the rotational matrix between spherical and Cartesian bases. So we can write it in a very different way as well. So we can write it in a very different way. Let me write it in a different way. The way we are going to use it while transforming. Okay, so let me write it here. I cap, j cap, and then k cap. So here r cap, theta cap, and phi cap. Okay, so see, now we have to write I dot r cap. Okay, dot product, because when we do the transformation matrix, then you will face these I dot r cap, I dot theta cap, I dot phi cap, j dot r cap, all these things you will face while transforming. So basically what we are here what we are going to find: I dot r cap, I dot theta cap, I dot phi cap, j dot r cap, j dot theta cap, j dot phi cap, and then k dot r cap, j k dot r cap here, k cap dot theta cap, and k cap dot phi cap. We are going to use this. So if you see here, first one is cap dot I cap dot r cap. So basically this one. So see, here is r cap, here is I cap. If we do dot product of I cap dot r cap, so only this will survive. These will go because I cap dot j cap will be 0, I cap dot k cap will be 0, because cos 90 would be 0. Okay, so now I cap dot r cap, or r cap, because dot product is commutative, a cap dot a dot b equals b dot a. Okay, so it's r cap dot I cap r, I cap dot r cap is one and the same thing. So I cap r cap dot I cap here, sine theta cos phi. So it's like sine theta cos phi. So similarly, r cap dot j cap, sine theta sine phi, r cap dot j cap here, this one is sine theta sine phi, sine theta sine phi, and similarly r cap dot k cap, or k cap dot r cap is cos theta. Similarly, from the second one, this I cap dot theta cap, I cap dot theta cap is cos theta cos phi. So it's like cos theta cos phi. Similarly, cos theta sine phi, cos theta sine phi, and minus sine theta, minus sine of theta, and phi cap, I cap dot phi cap would be minus sine phi. So it's like minus sine of phi, and cos phi, and 0. This is very important thing. You can see I cap dot r cap, sine theta cos phi. You can find all these dot products, and these dot products you would use while transforming the vector from the Cartesian to spherical, or from spherical to Cartesian. I hope you are able to you are able to understand what I am saying. I know it's a bit of mathematics, but I believe it's very simple mathematics. Now I'll tell you how to transform. Let's go with the example. Then you will understand. Example is, a vector is given by xi cap plus yj cap plus zk cap. What we have to do, we have to transform the vector to spherical polar coordinates. Okay, now see, I'll use this thing. Paste, let me put it here. Maybe I'll use it. I'll surely use it. Now let's go. So solution. Given vector, let me write it A as xi cap plus yj cap plus zk cap. Now we have to transform it. This is Cartesian. Now we have to transform it into spherical. So in spherical, it would be same vector A, and it has some r component, a r cap plus a theta cap plus a phi cap. So basically the unit vectors r cap, theta cap, and the phi cap are in spherical. We have to find this ar, a theta, and the a phi. Okay, it's very simple. Now you see this a vector and this a vector is same, because we're writing the same vector in the two Cartesian coordinate system. Okay, in the two coordinate system, not Cartesian. Okay, two coordinate systems. So if we have to find this ar, we can do dot product with this a vector with the r cap. Okay, so we can write ar as whole a vector dot r cap, and this a vector is same. This a vector and this a vector, it doesn't matter. So we can put in place of a vector, I can put this whole x I cap plus yj cap plus zk cap dot r cap. It's very simple. So x I cap dot r cap plus y j cap dot r cap. So this is same, this r cap and this r cap and r cap is same. I don't know why I sometimes write that r and sometimes write that r. Okay, so let me go with the conventional one. What I'm writing, this is r cap, this is here r cap. Okay, this is here r cap plus z k cap dot r cap. Okay, so let's proceed. This is the ar equals x is there, I cap dot r cap, I cap dot r cap. Here is the dot product, sine theta cos phi. So sine theta cos phi plus y j cap dot r cap, j cap dot r cap, sine theta sine phi, sine theta sine phi, and plus z is there, k cap dot r cap, which is cos theta, cos theta. So basically we are able to find the AR. So now here we are able to find this AR. Similarly, we have to find the A theta. So for that, we will do dot product of this A vector with the theta cap. Okay, so we can write A theta as A vector dot theta cap. So see, A theta equals A vector dot theta cap, and A vector is same, this. So basically x I cap plus yj cap plus z k cap dot theta cap. Okay, let me tell you one thing first, because I'll forget it later maybe. Let me put it downwards a bit. But see, in spherical polar coordinates we are writing AR, but we can't say there is x, y and z. In place of x, y and z, we have to introduce again r, theta and phi. So basically we'll use these equations, the basic equations of the Cartesian and spherical, these equations. X equals r sine theta cos phi, y equals r sine theta sine phi, z is r cos of theta. Okay, let me copy them here. Copy from here to here. Because in spherical polar coordinate system we cannot have x, y and z, so in place of x, y and z we'll use these things. Okay, so AR equals, I was actually going to do it in the later part, but let me finish it here. AR is, in place of x we have r sine theta cos phi, and sine theta cos phi is there, plus in place of y we have r sine theta sine phi, and there is sine theta sine phi, and then plus in place of z we'll use r cos of theta, and cos theta is there. So which implies AR equals r sine theta is sine square theta and cos square phi, plus r sine square theta sine square phi plus r cos square theta. So this is actually finally AR, whole written in terms of r, theta and phi. What happened? Okay, now this is done. So similarly we'll use the same thing here. So it's x x I cap, x into I cap dot theta cap plus y into j cap dot theta cap plus z into k cap dot theta cap. So we can put A theta equals, so in place of x we'll use again this r sine theta cos phi, r sine theta cos phi, and in place of I dot theta cap, I dot theta cap is here, cos theta cos phi, cos theta cos phi, plus in place of y I'll use r sine theta sine phi here, r sine theta sine phi, r sine theta sine phi into j dot theta cap, j dot theta cap here, cos theta sine phi, cos theta sine phi, plus in place of z is r cos of theta, k cap dot theta cap, k cap dot theta cap is the second one, so minus sine theta minus sine of theta. So basically I am able to write the 8 theta equals, so this is r sine theta and cos theta sine theta cos theta and cos square phi plus r sine theta sine theta cos theta sine square phi plus minus r sine theta cos theta. So a theta can be written as you can see we can see there is sine theta, see r sine theta cos theta, and we can take this r sine theta cos theta here common. Let's see, r sine theta cos theta, there is sine square theta here, cos square phi, sine square phi cos square phi, which is 1, then minus r sine theta cos theta. So this will go with this, it's 0, a theta equals 0. So similarly you can see a phi also doing the same methodology as I did. A phi you can find by doing the dot product of a vector with the phi cap. So basically you can write a phi as a vector dot phi cap, and in place of a vector you can write xi cap plus yj cap plus zk cap dot phi cap, and in place of x, y, and z you can put r sine theta cos pi, r sine theta sine pi, and in place of z is r cos of theta, and writing the I cap dot phi cap, j cap dot phi cap, z cap dot phi cap. From here you'll see that it is again 0. Okay, so so finally we can write a given vector as a r cap plus a theta cap plus a phi cap. So a vector equals, in place of ar we have this whole thing, r sine square theta cos square phi, r sine square theta cos square phi, r sine square theta cos square phi, where it is, yes, plus r sine square theta, so this is r cap, plus in place of a theta, in place of a theta we have, sorry, this is only ar, sorry, I haven't completely written the ar, so I am going to write as r sine square theta cos square phi plus r sine square theta sine square phi, r sine square theta sine square phi here, plus r cos square theta plus r cos square theta. This is r cap, plus this a theta is 0, a phi is 0. So we're done with that thing. Plus a vector is given by now. We can do one thing. We can take r sine square theta here common. R sine square theta, there will be cos square phi plus sine square phi plus r cos square theta, and this is r cap. So a vector is given by r sine square theta, this is 1, plus r cos square theta, r cap. So it's r sine square theta equal r cap. So a vector is given by this thing, okay, in spherical polar coordinate system. So how simple is that? So we have used actually this whole thing, and this matrix, actually I should say the dot product matrix, and if somehow we actually derived it from here, okay, from this r cap, theta cap, and the phi cap. So we did it, and so that would be all. Now you can transform a given vector in spherical to Cartesian using the same thing. You will face that would be the homework. So that would be the homework. If you have some given vector in spherical polar coordinate system and you have to find the Cartesian, so what you have to do, you have to find the ax I cap plus ay j cap plus az k cap. So if you have some vector here, let's say we have some r cap plus 0 theta cap plus 0 phi cap as a spherical polar coordinate vector, you have to find the Cartesian. You have to find the ax can be find as a dot x cap, and using this a vector here as this vector, do the dot product with this thing. So you'll face r dot x cap using this thing, using this thing whole, and you would be able to find it. I know it would be a good practice for you if you do it. So a vector dot y cap az would be a vector dot z cap, while putting this a vector as a spherical, that would, which one is given actually, okay, and then doing the dot product of then this thing r cap dot x cap theta cap dot x cap phi cap dot x cap r dot y cap r cap dot z cap theta dot cap y cap from the whole this whole this dot product matrix. Okay, I hope you understood the topic. Thank you so much.